Welcome back to another episode of the Modus Movement. As always, we are joined by Modus Nutrition's CEO and Chief Science Officer, Dr. Robert Pastore. Today, we are going to be talking about amino acids. Now, people talk a lot about protein and how important it is. We've discussed it on previous episodes, just about the daily recommendations for protein based on your activity level. But one thing that isn't talked about as much is amino acids, and that's likely just because of the lack of knowledge around it. Sure, there's BCAAs as a supplement, and I can tell you right now that half the people that are taking them right now don't really know why they're beneficial. They know that they're good for them and they'll take them, but they're not really sure why and what the purpose is for them. So Dr. Pastore, first, can you just kind of talk about amino acids and what they are?
Absolutely, and it's great to be back with everyone. So if I could just pepper in a little bit of organic chemistry, one of my favorite subjects, but I promise to put it in layman's terms. Amino acids are groups of organic compounds, and they contain one or more of what's known as amino groups, and that's how we know what type of amino acid it is. So think of a chain that has different types of components to it. They contain a nitrogen component and one or more of a group known as a carboxyl group. So don't mean to get complicated, but the reason I'm saying those statements is if you have any background in chemistry, those are all the ingredients of building things, making things that can become very important things for life. And what we used to say since I was first educated on amino acids are indeed the building blocks of life. And that's because of their organic chemistry characteristics. They can actually form things. Now, they're critically important to the facets of human physiology beyond just what we think. I've had a lot of interns over the years, Lexi, say, oh, hey, that's great. So amino acids will build things with proteins. And then they just look at it as a global view and say that, well, there's muscle that's made out of protein. And okay, there's hair and our skin. And I'm like, go on. Bone. And I'm like, okay, get smaller. So yes, hair, skin, bone, muscle, nails, keep on going. How about components of blood? We wouldn't even have blood without amino acids. Or how about hormones? It's impossible to have a hormone in the absence of an amino acid. Or how we're all communicating and hopefully being benevolent and loving to each other in life, having large amounts of happy neurotransmitters. I'm being honest, any neurotransmitter in general requires an amino acid. Hopefully you have more happy ones. So neurotransmitters, brain chemicals, all require these amino acids. And then my favorite statement is amino acids actually make other amino acids. So they're really kind of cool. So just their structure and just their shape, they tell us that they can build things. Their direction of side chains, known as their amino groups, tell us what type of amino acid they will be. And they're broken down into some categories. And I'd like to be old school with that. I know there's some change in the vernacular, but I love the terms essential, conditionally essential, and non-essential, as opposed to more modern terminology of categorizing the amino acids. All intents and purposes, they mean the same thing. So essential amino acids, Lexi, are those that we do not manufacture from other amino acids. So we have to, like it or not, consume them. Even if we were starving and we were breaking down our muscle tissue, we would be getting more of the non-essential amino acids into our pool, and we would be very, very sick in the absence of these essential amino acids. So I can't make this clear enough. And my memory, thank goodness, it should be really good. It's histidine, isoleucine, leucine, valine, lysine, methionine, phenylalanine, threonine, and tryptophan. And then also, there could be certain troublemakers that are associated with some of the essential amino acids, which I find fascinating, like histidine and histamine and their close relationship, allergic reactions, and all those interesting things. But these, I cannot stress enough, these are the amino acids that are crucial for our existence. And again, pardon that I'm really emphasizing this, we must consume them. We must consume them by eating in foods that are rich in these essential amino acids, and hopefully a dominant protein intake in our diet. And I promise I will touch upon that. But I would love to, if I may, continue on this theme, because the second part really was, if someone said to me, is there any way you could just give us one of the most important aspects you were focusing on in your clinical practice for professional athletes? Yes, I've talked a lot about the individual's relationship to food. and how that can affect absorption. But for me, it was also conditionally essential amino acids. What are the amino acids that under a normal environment would be considered non-essential? Maybe if, goodness gracious, there was a disease or an injury, for example, a severe burn victim actually has a higher requirement for arginine. But notice I never shouted out arginine in the essential amino acid category because it is listed as a conditionally essential amino acid. There could be things that happen to our bodies, hopefully not, that will make us have a higher requirement. I never was comfortable just with that definition because athletes that I would see and that we talk about a lot on this podcast are people that really put themselves in positions that normal lay people do not. They make their bodies actually suffer for a specific sport. If we talk about endurance athletes, ultra endurance athletes, ultra marathoners, you have people running 100 kilometers. That's like crazy for me. It's not crazy in general. It's just when I think the fact that I cannot fathom it as a human being is what makes it.
I have much respect for endurance athletes.
Exactly. I have the most massive respect for these people. I can't believe it. I know I'd be dead a quarter into that race walking. So I'm being flippant a little bit there, just a little bit. So it's those types of things that happen to our body that fascinate me. We probably need more types of specific amino acids, and it's why I believe in. I believed when I practiced in testing and identifying what those conditionally essential amino acids are. And I'll have more dialogue on that as we go on today about what individuals are absorbing. But that always interested me. And then lastly, there are these non-essential amino acids. And I'm happy to report I'm putting myself on the spot. That I remember most of these alanine, arginine, asparagine, aspartic acid, cysteine, one of my favorite amino acids, glutamic acid, glutamine, glycine, Prolene, serine, and tyrosine. We have to look back at that and see how well I did. Those are considered the non-essential amino acids, and they can be conditionally essential. I hope I'm making sense there.
Now, what would you say makes a non-essential amino acid conditionally essential?
Yeah, that's a great point. And if I may be so bold, it's for when I would run a laboratory analysis on a professional athlete and I would see a suboptimal level of one of these amino acids that should be considered non-essential, I now know I have a conditionally essential amino acid for that athlete. And if I may, I'd love to give one of my favorite examples that I really have never heard about it discussed on a podcast. I've never heard it discussed when I've been to conventions of my professional affiliations and have it come up. But it's something that I found to be so incredible, life-changing in my pro athletes that it was undeniable. And that is an amino acid that I mentioned when I rattled off a list of the non-essential amino acids, one known as serine. Serine, I've always felt just didn't get the respect that it deserved because serine does something that's so remarkable, Lexi. Serine, upon contact with an immature digestive enzyme known as a zymogen, can help it maturate and enhance human digestion. That is amazing. So if I have an athlete that has suboptimal levels based on a clinical analysis of their amino acids, serine, wow, I know immediately if I replenish that in that athlete and make sure they're consuming foods rich in serine, but also giving them serine as a form of targeted supplementation, which I call targeted amino acid therapy. It will raise that individual's level of serine and enhance their digestion and help my entire program or platform that I'm trying to instill upon this athlete foster. There's the greatest thing we could do is enhance digestion, removing foods that we immunologically react to and enhance the way we digest what we are consuming. Because I've always been a fan. I never liked the statement, we are what we eat. I've always been a fan of we are what we consume and fully digest. And that's a very important conversation with regard to conditionally essential amino acids. On a personal level, and I think I've spoken about this on the podcast before, and it's something I wear as a badge of honor, and I was forever changed by it. And it's the reason I didn't become a brain surgeon and started studying human nutrition and went off into different types of doctoral pathways in my life, is I have celiac disease. And I had a brutal time absorbing anything. I even didn't absorb medications, which, as you can imagine, is quite dangerous and alarming. But I once said this statement to an athlete. I said, hey, with my disease, I had horrendous digestion. I couldn't even dissolve an aspirin. So doctors would give me an aspirin for something, and pardon me for being graphic here, but we're talking about amino acids and digestion. And the one way we measure the quality of a protein is we used to even look at the output of an individual, which of course would be their fecal waste of how much they would put out. And we've improved those measurements over time, but it's important to know if an individual is not fully digesting and absorbing, a conditionally essential amino acid can become an essential amino acid for them. So the example I would give is everybody seems to have this universal understanding that blueberries are healthy. It came up on an interview I recently had with a healthcare specialist talking about the benefits of blueberries. Well, I said to this athlete, if I swallowed a blueberry whole and I was still undiagnosed with celiac disease and it came out of my body the way it went in, do you really think I absorbed all the beneficial components of that blueberry? And he immediately said, oh, goodness, no, doc. And I said, okay, well, let me ask you this question. Let's say I made 30 grams of protein out of whey, and I pummeled that shake with milk and whey and maybe put some antioxidants from fresh fruits and berries in there, and I drank that. But then shortly thereafter, or maybe let's just even say within 45 minutes to an hour, I had to run to the bathroom and had a loose bowel movement. Am I getting all the benefits of that protein? And could I have paused the digestive process, had incomplete digestion, expedited the proteins partially unfolded from my digestive tract, and eliminated them in a bowel movement? Would that mean I'm getting all the benefits of that whey protein? And it was right away understood that's, of course you are not. But there's still a disconnection between how we digest, how our gut feels after we consume certain foods, and how well we are digesting. So for me, it's always been on an individual basis. Historically, we know that burn victims, certain types of cancers, to be discussed with physicians, can't make that clear enough. There can be a higher incidence of amino acids that are required. Surgeries. I could use a personal story. You know, my late mother, when she was younger and she had colon cancer, one of the first things I did was use a specific type of dipeptide to help speed heal the resection of her colon after she had colon cancer. It was thankfully just surgical. It didn't require chemotherapy or radiation, but there was a removal of the necrotic area and then a resection. And I used a beta-alanine L-glutamine, knowing in clinical research that this form of the dipeptide glutamine could actually expedite the tissue healing process. And I've given lectures for various groups that were accredited on speed healing post-operatively. And one of the things I tried to drum home to the healthcare practitioners that took that class was on the importance of not only protein nitrogen balance, making sure you're getting high quality protein, but looking at the individual amino acids in a case-by-case basis, particularly when you have someone that went through surgery. And while I saw that in clinical practice, I had a lot of athletes that, my God, that's their life. You know, they want to go from X million to the hundreds of millions, and they want to have a long career. And this is, and those air quote, Lexi, long careers, as you know, with your sport, long careers are short careers when we look at the life of careers.
Absolutely.
A baseball player, it's a miracle if they get to 40. Let's not even talk about football. I mean, what Brady's doing in the Patriots is really remarkable. These are very hard, demanding sports, and hockey have always been so blown away just by balancing. In my day, guys were more in the 200-pound range. Now you have a lot of the speed and lots slimmer, more svelte hockey players in the 180 range. But regardless, just doing movements that are not normal for the body are all taxing, and they all have impacts on various parts of the body and result in a taxation of specific amino acid pathways.
Now, in your experience with running tests on all of these professional athletes, was there a trend that you saw where they were lacking the same essential, non-essential, conditionally essential amino acid?
Boy, that is a dynamite question. And you know, there really was. One of the biggest things I would see, Lexi, and it depended on the sport. It depended on, so my goalies, which you could imagine that's really not a great natural hip movement. A lot of wear and tear there. They would historically have, my humble opinion, this is just my personal opinion, what I would see, an increased requirement for the building blocks to collagen and connective tissue, which would be Prolene and Lysine, which end up becoming hydroxyproline and hydroxylysine, which I will go on the record and state, and you can look this up on PubMed, are absolutely essential for building collagen and connective tissue that my athletes would need. So I can actually tell you, I saw a correlation between my goalies and my relief pitchers. My relief pitchers and my regular pitchers, of course, but mostly the relief guys, because they would be really cold and then warm up as best as they could and then get out there and just throw heat for 4 innings and blow out their shoulders. And they too would have an increased requirement for proline and lysine and sometimes glycine, which, while glycine is known as this amino acid that can have this wonderful relaxation effect on the central nervous system, it plays a major role in building connective tissue and joint repair. Collagen precursor amino acids is how I would refer to the aforementioned 3: proline, lysine, and glycine.
And where would you get these 3 amino acids in a daily diet?
Yeah, you really have to be, if you're eating an omnivore type diet and you have animal proteins and specific plant-based proteins in your diet, you're not consuming anything that you're immunologically reacting to, because we talked about how that could block the absorption of a key nutrient, right? I had celiac disease. I was eating gluten. I was low in iron. I was low in B12. I was low in vitamin D. I was low in about 5 or 6 different amino acids. I was basically starving. So that can happen in a diet of a plenty. So let's just say that that's controlled for. You really want to make sure that you're consuming as many complete proteins as possible. And if you're on the vegetarian side, you want to look for plants that are very rich in those amino acids. And there's a superstar there. And I was so shocked how that was neglected. A dynamite source of lysine and is really pumpkin seeds. I loved working with pumpkin seeds early on in my career. They were a snack that I recommended. It's why I worked on isolating the protein from them so that I could get the benefits of the pumpkin seed, but amplify how much protein I could find in it, which would then amplify the nutritional content of each individual amino acid. And that's called the process of concentration, right? So if you and I, Lexi, had a bathtub and we put 1 teaspoon of sodium chloride in there, we could measure the sodium chloride in there. But then if we took a Dixie cup and put water in there and a full teaspoon of sodium chloride in there, we have a higher concentration of sodium. So if I could get more pumpkin seed protein into a smaller space and you wouldn't have to eat like a bushel of pumpkin seeds, I'm really amplifying those amino acids. So when I did that work in the lab, I was getting gangbusters levels of arginine, lysine, increasing the proline content, and then of course, all those crucial branched chain amino acids and all the essential amino acids. And pardon me that I'm signaling out pumpkin seeds. I'm not paid by pumpkin seed farmers. And yes, I did manufacture a product that contains pumpkin seeds, but I did that based on my knowledge of nutrition and hypoallergenicity. In all my years of clinical practice and looking for foods that individuals would react to immunologically, I never found anyone react to pumpkin seeds. So that I've had people react to different types of seeds, never pumpkin seeds. People react to different types of nuts. People react to different types of plants. And I understand you can't make something for everyone, but this really seemed to hit in a right zone for me. And another was cranberry seed protein. When I started looking at the data there, I felt it was kind of ignored. You know, I was like, man, we all get, again, that blueberry principle. I used to say in practice, if it's natural and it can stain your clothing, you should be eating it. So if it's obviously an artificial dye would ruin a white shirt, but if I dumped a bunch of cranberry seeds that I'm cooking on a stovetop all over a white shirt before going to the office, the fool I look. So I'm stained and that's not going to get off. But if I dropped a pear on my shirt, I probably could get away with it and work that day. Not slamming pears. Pears are lovely. Just saying higher antioxidant content in the staining-based ingredients.
That's a really interesting way just to think about it is, now, does this have antioxidants? What I'm eating right now, would this stain my clothes? I like that.
Yeah, thank you. It's always been a weird way I've tried to look at things to simplify some of the concepts, because I love the complexities. You know, when I would look at blueberries, I honestly would strip it down to, I think I got up to around 400 different beneficial chemicals found in a blueberry. So we use these governing terms that are wonderful and, no pun intended, I guess it is, digestible. But when we really want to look at the complexities of nutrition and the categories of things like polyphenols, it gets way more complicated. And the same is with amino acids. Like I would see a lot of people throw around, there's 20 amino acids and we only have to worry about 9, because that's sometime conditionally essential one, you know, and then there's the conditionally essential. And I find that fascinating because I would run 42 different markers for amino acids. I would run analytes of amino acids that can become other things because those are important too. Like creatine, like carnosine. Those are like taurine. Taurine is an amino acid-like compound that's made from amino acids. And one of the most important amino acids that becomes taurine is cysteine. And as you can see, we could go down a pretty big rabbit hole. So I don't want.
We could talk for hours and hours and hours.
I don't want to just talk at random. So I'm gonna pause there. But yeah, it's really fascinating stuff. So those key amino acids I found you could also get from plants, and you could do it in a way for individuals that may be vegan athletes or vegetarian athletes, or athletes that just, do you want to drink a cup of meat? I mean, if you're trying to, it just made so much more sense, and it was easier to bypass a lot of that digestive process if I could work in a lab and create something that would have those amino acids that are building blocks for connective tissue and all the other essential amino acids I just mentioned.
Now, in terms of muscle building, so we talked about collagen and joints, but for muscles, what are the important amino acids for building and repairing?
For me, I think that the amino acids are, and pardon that I'm going to say all of them, all of the essential amino acids, and identifying the conditionally essential amino acids are critical for building muscle mass. That's just hopefully a message I'm making clear. Having said that, branched chain amino acids really are the rock stars for protein building in the human body. I mean, the science is just too plentiful around that, Lexi. They were a focal part of my practice. And pardon me if I could go back to the organic chemistry reference that I use. It's again how they're built and what they look like structurally. They have these aliphatic side chains with a branch. And there's only 3 of these proteogenic, which means protein building, essential amino acids that have that structure. And that structure, and if we just simplified what I said and say, wait, doc, so you're saying that there's these amino acids that are a specific category, and then they have branches on them, and there's 3 of those. Yes, that's how they got their name. And they're essential. So what are they? They're leucine, isoleucine, and valine. And I go back to call those the rock stars. They're essential, so we can't make them. We need to appropriate them, meaning we need to consume them. And the data on these is with physical exertion, Lexi, like a lot of what you do, incredible strength training, to even extreme rest, like an injured athlete, branched chain amino acids will still stimulate muscle protein synthesis. And that, I've had athletes say, whoa. So it's not just about me eating healthy foods. I have to make sure I'm getting adequate amounts of total protein and protein that's rich in branched chain amino acids. Bingo would be my response.
Now let's kind of walk through the digestion process. So I have my shaker. I add either a scoop of branched chain amino acids solo as an individual supplement, or 2 scoops of Modus, shameless plug there, with my 7 grams of branched chain amino acids. When that enters my body, what is happening with these branched chain amino acids to stimulate muscle protein synthesis?
Wow, I love that statement, and I'm going to cover 3 areas if you don't mind. Firstly, because those are single amino acid isolates, they don't require full digestion processes. So if you were eating a piece of chicken which contains the branched chain amino acid L-leucine, there would be an unfolding process which breaks down the polypeptide chains into smaller peptides and then into amino acid chains and then into single amino acids. That transpires in the stomach over a period of time, depending on the food that was consumed and what was consumed with it. Then it is completed in the first part of the small intestine known as the duodenum, and absorption takes place throughout the rest of the intestines, duodenum, jejunum, and ileum. In the case that you mentioned, there's this expeditious absorption of those branched chain amino acids that you took as an isolate that are already separated from the proteins that you consumed, and they will immediately start acting on several pathways. Part 1 is known as 4E binding protein, and that is a pathway of muscle protein synthesis. Another one is better known as mammalian targeted rapamycin, complex 1, or mTOR to make it a little bit more simple, complex 1. And that is an amplification under stressing of the muscle, like lifting weights, performing a sport, doing something that's active that taxes the muscles, that upregulates muscle protein synthesis. And then there's actually my favorite, which is P70S6 kinase. And that metabolic pathway is one that stimulates the prevention of muscle tissue breakdown by the branched chain amino acids during injury or rest. So what categories did I love that stimulation pathway? My linebacker that's injured. We know from a ton of research that they're losing upwards of 50 grams of amino acids from their muscles, Lexi, in a week of time. And in my mind, I know that with nitrogen balance, making sure we are consuming enough nitrogen to losing nitrogen, keeping that in balance, that can go, textbooks when I was in graduate school, it was 320 grams that could transpire in a given day. And yes, 80% of that protein, that nitrogen that's lost, is recycled to make other conditionally essential amino acids, but not the essential ones. So 20% of that is yielding nitrogen and carbon skeletons that we gotta put back. So if we examine that loss and say like 7 grams of nitrogen is excreted into the urine, that's the equivalent of 40 grams of protein. This is why I've never been a fan of low protein diets, Lexi. I'm so sorry, but I'm brainwashed from having excellent professors, and then of course practicing and seeing the largest, strongest athletes and making machines out of people. I just never accepted the low protein pathway. Never was gonna work. I never was gonna get a contract. I knew I needed to make sure they were getting those key amino acids. But staying on point with those branched chain amino acids, there's the last thing I want to throw out there that I don't see enough in literature. And I was able to prove it and verify it when I would measure organic acids. And that is the difference between giving a pro athlete branched chain amino acids together versus just leucine alone. And I get it. Leucine is just dynamite. Leucine can actually make an inefficient, poor quality protein even better by rallying the troops, firing off specific aforementioned pathways of stimulating muscle protein synthesis and rescuing a suboptimal protein as it's being digested to facilitate muscle protein synthesis. And I've seen those studies, taking really lame plant-based proteins and like rice protein and hemp protein and adding a little leucine, 2.5 grams to be exact, 3 grams, and making it work better. But when you mix the 3 branched chain amino acids together, there's data that you're actually increasing within the muscle citrate and malate. These are very important organic acid salts that play a role in the tricarboxylic acid synthesis pathway, which is the production of adenosine triphosphate, which is cellular energy. Whose muscles don't want more energy if they're performing a sport or if they're performing an activity? Or Lexi, if you're going to go into the gym and really want to get a pump, you need that cellular energy. So that's why I've always been a fan. One of the reasons I've always been a fan of branched chain amino acid dominant intake in my competing and professional athletes.
Now, when you are consuming branched chain amino acids, how long approximately does it take from the moment that you drink it to get to work within your body, and how long do those effects last? So let's say I'm having a standalone individual BCAA product. There's no additional protein added in it. How long is that going to stay in my system and benefit me?
In a typical healthy individual, healthy athlete, it's absorbed within minutes because there's nothing that's impeding digestion, and you will get those beneficial effects that I have seen, the data that I have seen, and I have personally worked with top athletes for 30 minutes to 2 hours of time. I also am a big believer in the amino acid pool. So and this is going to be a little bit of a difficult way to answer this question, so please let me know if I'm not being clear. The amino acid pool, we don't store protein. We need to eat protein. We do have an amino acid pool throughout the lymphatic system that helps regulate an amino acid balance in our bodies. Amino acids do amazing things. They regulate acid and alkaline balance. The amino acids are the whole reason we have a specific range of pH for our blood to prevent alkalosis and acidosis that can transpire in certain disease states, which are horrible. And for normal, healthy people, they're critical for our homeostatic mechanisms. So if someone is doing everything right and they're healthy, these amino acids will last, and these branched chain amino acids will last and become part of the amino acid pool for what's not utilized to be utilized throughout the rest of several hours. In individuals that may have a suboptimal levels of these, that are taxing their bodies, that are eating lower protein diets, they're really going to be utilized, and that's going to be it. And then you're going to preserve that muscle mass, and then it's going to go away through the process of nitrogen balance. If I may be controversial for a moment, and sadly I have to be, there's like a storm coming that I'm uncomfortable with, and it's just really the hypo consumption of calories and hypo consumption of protein. And then there's a caveat that says, but if you're strength training and you want to preserve muscle, have that one bolus of 30 grams of protein, work out, and then the rest of the day basically starve yourself and make sure your protein intake is extremely low. That is unbelievably not logical for so many reasons. But that's not how the body works. That's not nitrogen balance. You will lose that muscle mass over time. Again, don't go any further than looking at the Gatorade Research Institute on muscle loss and protein loss during a professional athlete's injury while on the bench or through rehabilitation. It is real. It is a problem. It's always an uphill battle when you're dealing with a professional athlete to keep them in positive nitrogen balance.
Now, if we kind of jump into protein, so we've consumed our BCAAs, great. Now, if we have a standalone protein supplement that you're not intolerant to, or we have eggs, or we have chicken breast, how do those protein structures be broken down into amino acids?
Yeah, and depending on each food, that happens over many hours, which is what we want, right? So you mentioned eggs, throw in chicken breast in there, throw in a steak. That's something, that digestive process that's going to transpire over a minimum of 3 hours. We consume the food, the process of chewing known as mastication, the real major enzyme in saliva, which is an alkalinized environment or should be an alkalinized environment, is ptyalin, which is more of a starch-based digestive enzyme. So it's basically not really doing anything during that process of mastication. If you're just eating a solo protein, that then hits the first part of the stomach, where we start the secretion of hydrochloric acid and various peptide unfolding amino acid enzymes. Notice amino acids build digestive enzymes. Isn't that cool? They're so important for everything. So you can't even digest the food you're eating to get the amino acids if you don't have amino acids. I love that. That's pretty cool. So then we have this unfolding process that transpires there with trypsin, chymotrypsin, hydrochloric acid. Get to the end of the stomach over a period of hours through that churning digestive unfolding process. I prefer unfolding because you're not really digesting them and absorbing in the stomach. You're unfolding proteins into smaller chains known as peptide chains. Then it goes through the pyloric sphincter to the first part of the small intestine known as the duodenum. There's a sodium bicarbonate wash that transpires, and now we're back into an alkaline environment from an acidic environment, and that's where these enzymes work very, very well. Through exposure of some of these unfolded peptides, particularly the aforementioned amino acid serine, you then have an instantaneous maturation of zymogens, which are immature digestive enzymes that hang out throughout the brush border of the first part of the villi and microvilli of that small intestine, these finger-like projectiles, of which I had none due to celiac disease for a period of time. Those are crucial for that digestive process, and deep tucked in down in between those folds are known as lacteals, and that's where fat soluble vitamins and certain key nutrients will be absorbed through that pathway and essential fatty acids. So that whole area in the small intestine is crucial for the rest of the unfolding and utilization of those amino acids. Hours-long process.
In that process in the small intestine, when you are intolerant to something, so I'm lactose intolerant, I have a whey-based protein shake. My stomach's a little bit upset, but what is going on in the small intestine?
I don't know why I just thought of this. Fire in the hole, and someone pulls a chain and everyone ducks and we just lost everything. So what you did is you expedited transit time. You artificially or chemically insultingly expedited peristalsis, the normal wave-like contractions of the small intestine that should normally move post a complete digestive process, food from waste material throughout the small intestine to then through the ileocecal valve to the cecum into the large intestine where it is gotten rid of. So you would see maybe stools that are floating and they're not sinking. That means there's more fat there. So you did not get the benefit of that salmon meal you might have had around the time you had that whey protein shake. Salmon takes 3 hours to digest. You gun that whey protein shake. It's making you have an abnormally loose bowel movement within a short period of time, let's say 30 minutes, Lexi, with a lactose intolerance or dairy allergy. You kind of lost the farm there. You bet the farm on that shake and lost your key window of absorption. We can't go backwards in digestion. This was your moment. Someone once said to me, you can't unring the bell. And I really like that. So once the components got into the large intestine, you're just reabsorbing water which is one of the ways we prevent dehydration. So you're not getting the benefits of that protein if it was expedited throughout the gastrointestinal tract, and pardon me, but other things that went with it.
I'm kind of picking on the supplements that when you walk into a health food store, you see on the shelves, and they're really upsold and talked about. So what are your thoughts on glutamine as a supplement and creatine as a supplement?
Glutamine is one of the most abundant amino acids in the human body. It's on my list that I talked about today. As a conditionally essential amino acid, it absolutely helps heal tissue, and there are many, many, many cases where I recommended its supplementation based on an analysis. Typically, because it is such an abundant amino acid and we make it from other things, if you're eating a dynamite diet or you're consuming an exceptional protein shake, you're getting enough glutamine. But there's cases where it should be individualized. You may need it. Have I seen it do incredible things in someone who was off the charts high in glutamine and decided to add it to their diet after I did a full analysis on them? No. Can you add more gas to your tank after you filled your gas tank? No. So I just didn't see the value of just a blanket, everybody should be on glutamine. And I'm not we could have a whole separate show on this, but there is some areas of where glutamine may not want to be used as a single isolate supplement. And that should be discussed with individual physicians, with anything, of course. With regard to creatine, I really think it's one of the most well-studied amino acids. It's made from arginine, glycine, and methionine. So if individuals are really healthy and they're getting, you guys may remember that I mentioned methionine, and that's an essential amino acid. Glycine is conditionally essential. Arginine is conditionally essential with a little bit of a step above, because in certain areas we feel, and the clinical literature feels, it may be borderline essential, like the aforementioned victim exposed to, burn victim exposed to that type of tissue damage. So if all those are great in your body and you're not a professional athlete or you're not training to lift competitively, you're probably making enough. If you are someone that is a professional athlete or training competitively, or there's even some evidence in sarcopenia, there's evidence even in brain-based diseases, I really love creatine from an NSF Sport certified source. What came out of some of these studies, Lexi? Creatine is critical to a process known as rephosphorylating adenosine diphosphate. So EDP is critical to become ATP within a muscle, adenosine triphosphate cellular energy, so you actually have, be able to contract your muscle and work out. We deplete that, of course, while you're doing reps, right? So Lexi's doing reps during intense exercise. Your ability to continue those reps are largely dependent upon the amount of phosphocreatine stored in your muscles. Studies have shown when those phosphocreatine stores become depleted during intense exercise, your muscle energy will completely tank due to the inability to resynthesize ATP at the rate required to sustain this high intensity exercise.
I know that feeling.
Yeah, and creatine supplementation seems to expedite replenishment. So I can see it as a really great thing. I just do think it's, do I think creatine could harm anyone? No, but talk to your doctor about it, get a really clean source, get something that has a big old stamp on it that says NSF certified for sport. We have a whole show on that. Listen to that show. If you did, re-listen to that podcast. But yeah, I think creatine's a dynamite supplement, and there's an enormous amount of literature on it.
And as a takeaway for our listeners today, what would you say are some of the top foods to be consuming to ensure that you have enough essential amino acids for sure, but also conditionally essential and non-essential amino acids?
Yeah, that's a great point. And that's really whole protein. So if you are an omnivorous listener and you're an omnivore and you eat a wide variety of foods from the animal and plant kingdom, continue to do so. Animal proteins, there's no denying it, contain complete proteins. They contain the lion's share. They have all of the essential amino acids, all of the conditionally essential amino acids. And all you would need to do is have a variety of them. Don't just eat one thing. Don't just say, oh, I'm an omnivore, I only eat Dover sole. Have Dover sole, have grass-fed red meat if you're open to that, because you're not going to get the creatine in Dover sole that you would get in the grass-fed red meat, right? But so if you're open to that, that's awesome. And I don't want to ignore the plant kingdom at all, because I cannot make this clear enough. you're not going to get the arginine you're going to get from pumpkin seeds in animal foods. So make sure you have this big, wide, varied diet of plant-based protein sources and animal protein sources. If you're not someone that is an omnivore and you are vegetarian or vegan for whatever reason, and bless you, I support that. And I would highly recommend going out and fortifying your diet. Even animal protein eaters should fortify their diet with a healthy protein supplement. We can do a whole show just on nitrogen balance. Go out and get the highest quality protein supplement that you can find that contains all the essential and non-essential and conditionally essential amino acids. They exist, they're out there, and make sure it has NSF certification for sport on it. And your best bet is looking for something that has a large component of pumpkin seed protein in that formula.
Awesome. So if you do have any questions about amino acids, feel free to reach out to us. It is help, HELP, @modusnutrition.com. All of the questions that come into that inbox will be sent directly to Dr. Pastore, and he can answer them either via email, or if we get this question a lot, or if it's a super awesome talking point, we will do it in a future podcast. Thanks so much for listening, and we will see you next time on the Modus Movement.
Thank you. Take care.